Okay, to Alpha, good afternoon. How do you do today? Okay? Hmm? Everyone is okay?
Okay, okay.
Okay, wow, very good. Hmm. Having your lunch yet? Already eat your lunch? Or after this? Not yet, after this. Me too. Same lah, same with me lah. After this, then I will go for lunch. Alright, never mind. Okay, thank you for joining my class. This is the Pdpr version 4 lah, yeah. Right. So before we start our lesson for today, I need to tell you a few things lah, yeah. Okay. Number one, can you see my presentation? Sorry, can you see my screen sharing? Oh, can ya? Okay, very good, very good. Thank you very much. All right. Okay, now I'm showing you our Telegram groups, yeah. Right. I think you all already get your new timetable for version 4. Already got your the timetable right for version 4 starting today. Hello? You already got right? Can you hear me? Can okay. So can you tell me what I'm sharing right now?
The timetable.
My timetable, yeah. Okay, this is my personal timetable for version 4, yeah. Effective 26th of July 2021, meaning from today. Okay, so like usual, our meeting for science class for 2 alpha is 3 times per week starting from Monday. I will start at 12:45 afternoon, yeah. And then the next class is on Tuesday, right? Can you? I hope you can see it. The next class is on Tuesday. We'll start at 12 afternoon. 12 afternoon. Tomorrow. Okay, Tuesday. And then the next class is on Wednesday. And then maybe I will start at 10:45 in the morning. So we have all together three meeting per week. Okay. Is it okay, class? Right. So this is the new timetable for version 4, PDPR version 4, effective today until notice yet, right? So that is matter number 1. Okay. If you want to see the timetable, also if you go to our Telegram group, I also already uploaded the new timetable for science, yeah, for my class 2 alpha. Okay, next one. Okay. All right. This is the calendar for August, right? As you know that we are continue you are continue be learning from home, starting from 26th of July until 31st of August 2021. Okay, for how many weeks, class? How many weeks you think here? How many weeks? Oh, just for another. Okay, this is our first week. This is our first week for PDPR version 4. And then we have second week, third week, fourth week, and fifth week. We have 5 weeks to go, until 31st of August 2021. All right. So how about our holiday? Our holiday, only 2 holiday. 10th of August, Awal Muharram, and then 31st of August 2021. This is for the Merdeka Day. Okay. So altogether, we have 5 weeks more for PDPR. And then the government said that maybe on 1st September, the school will be reopened. But I do not think the school will be reopened on 1st September. 1st September, 1st September is only for Form 5 student because they want to, they have SPM examination, right? Maybe for Form 4 and Form 6 student, for SPM and for STPM examination, they need to go to school, maybe start from 1st September. And then how about the rest of the Form 1, Form 2, Form 3? Maybe, this is, I'm guessing. Okay, I'm guessing that we are continue learning from home until end of this year lah. Okay, this is the worst case scenario lah. This is the worst case scenario that I can imagine. Okay, they said the school will be reopened on 1st September, but looking at the current trend, looking at the current cases, it is unlikely it will be reopened at 1st September. Okay, yesterday how many cases, class? Yesterday 17,000 all over Malaysia. In Perak, raised increased to 600 plus cases, and then in Sungai Siput 61 more cases were detected. Okay, so I hope you all be patient, all right, and then try to join my class, try to do my work, what we call you try your best, you try your best to join my class. Of course, there is an obstacle, there is a challenge. Online class is not just like regular class when you are face to face with a teacher and friends, but never mind. This is during the pandemic. We must adapt to this situation right now. Okay, is it clear, class? Do you know what I'm talking about? Because I hear no response from you. Okay,
Okay.
Okay, very good. I hope you understand the situation. Very hard for me, and of course very hard for you also, because you need to follow the actual timetable, right? But don't worry. I will be lenient on this. Don't take it so what we call don't be stressed on it. The most important things right now is you keep your family, keep yourself healthy, and then follow the SOP lah. That's all. All right. Okay. So this is the second matter. I hope you understand. So we have another 5 weeks before they said they want to reopen the school. I don't know whether they want to reopen or no. So we wait and see. But we have another 5 weeks online learning. Okay, the school will be closed until the 31st of August 2021. Depend on the case, right? Okay. Okay. All right. So, okay. The third matter is beginning from today. All right. There is an attendance. Official attendance will be taken, and then those who are unable to join the class the name will be taken to the school to be take action. All right, but I think to Alpha is okay lah. Because after this I will give the video recording, and then if you watch the video recording, if you're unable to attend the online class but you watch the video recording and then you do the class, meaning that you are present, don't worry. But to Alpha I think no problem lah with attendance. Okay, right. And how about the workbook? Until we already discussed the question until page 91. Is it true? Do you have any question? Because I think last meeting we discussed the question on workbook, right? Any problem until page 91, isn't it? Is it true, class? Until page 91, your workbook? Hello? Series and parallel circuit and the calculation. Is it okay? Can you hear me?
Okay.
Yes. No question, yeah? Until page 91, right? So we already finished. We already finished series circuit and then parallel circuit, their formula, and then the Ohm law. Okay. I think for today, I will start new chapter. Not new chapter lah, yeah. The new subtopic for chapter 7. That is 7.3. We're going to learn about magnetism. Is it okay? Can you see my presentation?
Yeah.
Can, magnetism, yeah. Chapter 7, the last subtopic for chapter 7, electricity and magnetism, is 7.3 magnetism. Okay, right. So I will continue the lesson for today, yeah. All right. I think you know what is magnet. Okay, magnet is this material, right? Magnet, when you attach an iron, for example, a ferrous iron, okay, a metal, ferrous metal, sorry, yeah, a ferrous metal such as iron, it can be attract to the magnet. This is what we call a magnetism. So next one, the properties of magnet. You need to understand what is the properties of the magnet, right? If I can draw the magnet over here, the example of magnet lah, this is the example of magnet. This one. Okay, this is magnet. Right, this is an example of magnet. Right, we have two polarity over here, right? Do you identify N and S? N is north and then S is south. And then the magnet over here is attracted by the iron, by the ferrous metal or the iron. So number one, in this topic, you must understand what is the properties of the magnet. Okay, so there are four properties of a magnet. Number one, it will attract what we call magnetic material. Attract magnetic material. So anybody can tell me what are the example of magnetic material? Such as what? The most common magnetic material is
Compass.
yes.
Compass.
Compass. Sorry, magnetic material meaning the substance that attract to magnet. Material or the substance or the things that attract to magnet. Attract to magnet. Such as iron. Such as iron. Iron is the material or the metal that attract to magnet. Okay, but you must what we call remember, not all metal attract to the magnet. For example, if I ask you gold is one of the metal, right? Or aluminium or copper. Okay, these three what we call substance is metal. Okay, my question is, copper, gold, and aluminium attract to the magnet or no?
No.
Yes, very good. Copper, gold, and aluminium cannot attract to the metal. Only certain metal attract to the material, but most commonly, the metal is what we call iron. Iron is the what we call a ferrous metal. Ferrous metal. Okay, that can attract to the magnet, meaning that the magnet can what we call pull the iron near it. It will attract the magnet. Okay, can you understand this? Copper, gold, aluminium, although it is a metal, but it is not a ferrous metal. It cannot be attracted to the magnet. Right? Is it okay, class? All right. Okay. Good. Okay, thank you very much. Okay. Okay, next one. The properties number 2. Properties number 2, it has poles. One is north, one is south. Okay, one is north and south. Okay, for example, over here, if I can draw One is north, and then one is what? One is north, and then one is north, and then one is south. This is what we call a pole. P-O-L-E. N stand for north, and then S stand for south. That is the second properties of magnet. The next one. Okay, number 3. All right, number 3. This is number 1. This is number 2. Okay, number 3. Like poles repel, unlike poles attract. Okay, can you understand understand the statement? Like poles repel, meaning the same polarity it will repel. A different polarity it will attract. Okay, for example, you have a magnet here. Okay, if I can draw a piece of magnet here. Okay, one is this is example of magnet lah, yeah? All right. Okay, one is north and one is south, and then this is another magnet here. One is north and one is south. Okay, right now the magnet here, south and north over here. This is south, this is north. What happened to the different pole, right? Different polarity, meaning it will attract or it will repel here.
Attract.
Attract or repel? It will attract. It will attract to one another. Okay, A-T-T-R-A-C-T, and then vice versa lah. Vice versa. For example, if I can draw another magnet over here. Okay, this is north, and then this is south. Okay. Okay. What happened to the magnet here? It will attract or it will repel? This one. Same polarity, right? Sorry.
Repel.
Okay, good. This is same polarity, north and north. It will repel. Okay, this one it will repel. It will not attract. Okay, can you understand this? The third properties of magnet. Now this is the third properties of magnet. Okay, next one. And the next one, number 4. Number 4, freely suspended magnet show north south direction. Okay, what's the meaning by freely suspended magnet? A freely suspended magnet, for example, if you try to float the magnet, all right, on the surface of water, all right, the what we call the north polarity, the north, it will what we call just like a compass line. Compass is a free suspended magnet. I will show you the picture of compass. Okay, for example, compass. Okay, I will try to use this picture, yeah. For example, this one is the compass. So inside the compass, we have free this is what we call a free suspended. Free suspended. Free suspended meaning it just suspended on the tiny piece of shaft over here. Okay, and then the north polarity here will always directed to the north pole, and then the south already always what we call show the opposite direction. Free suspended. No matter how you orientate the compass, no matter how you put the compass, the north will always show to the north, and then the south will always show to the south. When you try to suspend the magnet or you just suspend the ferrous metal or the iron inside the tiny shaft over here, it will always continue to north, show north, and then at the opposite, it will always show south. Can you understand this, class? Okay. All right, good. So we continue. So make sure you understand the 4 properties of the magnet. 4 properties of the magnet. Yeah. All right. Okay, next one. Magnetic field. Okay. Topic number 2, right, is what we call by magnetic field. Okay. I will show you this picture. You remember this picture? You still remember this picture? This is an example of typical magnet because it has one north and south. Okay. We have 2 polarity over here. One is north, one is south. And then when you try to spread the iron filling, this is iron, yeah. The black powder here, the black powder is what we call an iron filling or iron powder. This is iron powder. Okay. When you try to spread the iron powder near the magnet, the iron powder will attract to the magnet, and then it will create what we call by magnetic field. Magnetic field. Okay. I will try to draw the magnetic field over here. Yeah? The magnetic field is like this. This is the magnetic field. If I can draw the magnetic field according to the what we call the lining of the iron powder over here. Okay, this is magnetic field. All right. So can we see the magnetic field without the iron powder? Can we see it or not? Without iron powder, yes, very good. Without iron powder, we cannot see the magnetic field. We can only see the effect of the magnetic, right? When we put iron, for example, we put iron near the magnet, the iron will attract to the magnet. But in order to see the magnetic field, you need to pour or you need to spread the iron filling around the magnet. Then you can see the magnetic field. Okay, now these are the example of the magnetic field of the magnet, right? Okay, next one. I will show you another picture if I have. Okay, this is another example of how we can detect the magnetic field on magnet. Can you see this? I hope you can see this also, yeah? This is how we detect the magnetic field on magnet. We have S, south polarity, and N, north polarity, and then we try to spread the iron filling, and then it will show the what? It will show the magnetic field. Another one for north over here. Magnetic field. Okay, this is the magnetic field. Can you understand this, class?
Yes.
Can, okay, very good. Right. Magnetic field. Okay. Also, you can detect magnetic field by using what, class? You can also detect magnetic field by using what?
Compass.
Yes, very good. By using compass. Okay. That's why when you are using compass, you cannot read the compass near the magnet, or else it will haywire. Okay. The compass, if away from magnet, is always showing the north direction. Yeah? But if near the compass, you can see the needle inside the compass here will be like this. Can you see? Can you see my drawing over here? So this is the what we call the magnetic field of a magnet. Okay, but away, if I can draw, if away from the magnet, the compass will always show north direction. But near the magnet, because the magnet is more stronger inside the magnet, this is the needle turn. Okay, the what we call the position of the needle is like this. Okay, do you understand the class? Boleh this is the what we call the position or the formation of magnetic field. Okay, right. So my question is, I want to ask you whether you understand this or not. If there is no, imagine if there is no magnet. If there is no magnet, so what is the position of the compass, the needle position? Is it pointing to one way or different way? Different direction or same direction if there is no magnet over here?
Different.
Different or same? Again, my question is, if I take the magnet out, never mind, I will try to draw the picture. Okay, wait for a second. Right, so if I have a magnet over here, if I have the magnet, one is north and one is south, and then I put compass 1, 2, 3, 4. So what is the direction of the compass? Direction of the compass will be like this. Okay, because the needle of the compass will follow the polarity of magnet. Okay, it will follow the polarity of the magnet. Okay, if I put the what we call magnet here. So what happens if I remove the magnet? If I remove the magnet, what happened to the needle inside? Same direction or different direction? Right now, there is no magnet. So what happened to the needle inside? What do you think? Again, I can't hear you. Same direction or different direction?
Different.
Different direction. Are you sure? One mantai, same direction. Same direction, yeah. If I take out the magnet, the direction of the compass will be same. Will be same. Because now it does not follow the polarity of the magnet. Now it will follow the polarity of Earth magnetic field. Now, okay, it will not. If I put compass here, it will follow the polarity. Sorry, it will follow the polarity of the magnet. If I remove the magnet, it will follow the polarity of the Earth magnetic field. Depending on the what? Depending on the where you put the position of the compass lah. So if there is no, remember class, if there is no magnet, the needle inside the compass will show exactly same direction. Same direction of what? For example, here this is north. This is north. Same direction up. Okay. If I put back the magnet, okay, if I put back the magnet over here, north and south, if I put back the magnet, which magnet is stronger? The what we call the magnet on the table or the Earth magnetic field? Which one is stronger?
The table.
Yes, very good. The table magnet will become more stronger, right? More stronger than Earth magnetic field. So you can see it will follow the magnetic field of the magnet, not the Earth magnetic field. Can you understand this? Yeah? Right, class, yeah? Okay. All right, so we continue. So you need to remember this, characteristic of magnetic field line. Okay, this is the last what we call lesson for today. Characteristic of magnetic field lines. Number one, the characteristic number one. Where is it? The magnetic field lines begin from the North Pole and end at the South Pole. This is number one, you must remember. Okay, it always begins from north. Can you identify the arrow here? Always start from north and then enter the south. Coming out from the north and then enter the south. This is the first characteristic. You must not confuse about this. I will draw again. Coming out from the north and enter the south. This is the where the magnetic field lines begins. Okay, maybe later on question, it will ask you how to draw the magnetic line. Okay, always start from north. Okay, class, is it okay? Number two, the magnetic field lines are closer to one another where the magnetic field is stronger. Okay, I will try to zoom in. Okay, never mind. Magnetic field line closer to one another is the strongest magnetic field. For example, like this. I will try to draw you again. For example, like this, I will try to draw the magnet. Okay, this is example of magnet north and south. Okay, and I will try to draw the magnetic field lines here. 1, 2, 3, 4, 5. Okay. Begin from end. Begin from end. So the arrow will be like this. The arrow will be like this. Is it true, class? Is it true? Drawing like this? Okay.
Yes.
So, okay, very good. So you can see I'm using the red line over here. Which one is stronger? The red line here or the green line? Which has the stronger magnetic field? The green or the red line? Which has the highest magnetic field? The strongest magnetic field, green or red?
Red.
Strong. Okay, so wait. Strongest magnetic field. Okay, strongest magnetic field is on the red one, not the green one. Because why? Because the what we call the closer to another. All right, the closer to one another, magnetic is stronger. This one, can you see here? The first line here, this is the closer magnetic line, so this is strongest magnetic line. The green one, because it is furthest away from the pole, so the magnetic field here is less strong. It's weaker over here. Okay, can you understand this? Can it's based on the direction or the range or the what we call the distance between both lines over here, right? Okay. And number 3, the magnetic field never meet or cross. It will never meet or cross. Okay. What meaning meet or cross? For example, here, if I have another, okay, if I have another, what we call I will draw you another things. Yeah, I will draw you another one. Okay. Oh, sorry, never mind. I will show you the picture over here. Okay, for example, like this. It will not cross each other. What does it mean? It will not cross, meaning that I draw like this, this one, and then this one. There is no such thing as cross. This is what we call cross. The magnetic field will not cross each other. Okay, it will not cross each other or what, or never meet or cross. This one, if you draw like this, so it is wrong. If you draw like this, it's wrong. Okay, so can you understand me, class? It must
Yes.
draw. You must draw like how? How must you draw it? Okay, you must draw it like this lah, yeah. You must draw it like this. About like this, eh? Okay, one up over here, and then this one, another is up. Okay, it will not. This one this way. It is the correct way to draw the magnetic line. It will not cross. It will not cross. Like this, can. Okay, can you see the X over here, class? Okay, I want to ask you. In the area X, is there any magnetic field, force or no magnetic force? Got magnetic force or no magnetic force?
No.
X. Okay, very good. You just remember, yeah. Area with no magnetic field line, there will be no magnetic force. There will be no magnetic force over here. Magnetic force only between the line, the nearest line over here. All right. All right. Okay. Any question? Any question before we stop here? You have any question to
No.
ask? No, yeah? Okay, just wait for a moment. All right. Okay. If you have any question, you can ask in our Telegram groups lah, yeah, class, yeah. So I think I will stop here. We continue the class on online class. I will continue on tomorrow. Yeah, tomorrow we have class. Yeah, tomorrow I will start at 12 in the afternoon. Okay. So I think I will stop here. Thank you for your focus and participation. I will see you all again tomorrow. And then exercise, I will try to give you later after the class. All right, class? Is it clear?
Yes.
Okay, so thank you very much. We see you all back tomorrow, right? At 12 afternoon, yeah, 12 in the noon. Okay, you can leave the class now. Bye-bye.
Okay, teacher.
Thank you, teacher.
Thank
Thank you,
you.
teacher.
Thank you very much. Thank you. Thank you.